Let's take a look at our math minutes. All right. Due to time, let me read through the answers real quick. Number one, 43,465. Number two, the 1 should be circled. Number 3, 1,330. Number 4, if we put it on that number line, it's closest to the 1 because 19 out of 20 is almost all of it. Almost all of it. Number 5, we are looking at multiples of 48. We're looking at multiples of 48, so that would be how many? Ooh, not quite.
Wait, are we number 5?
Yep.
192.
192, so it'd be 48 times 4. And number 5, it's already lined up for you, 35 and 26 hundredths. Number 7 is 4. Number 8, to find the perimeter of the square, there are 4 groups of 4, so 16, and the label would be units. And number 9, 3 hours and 10 minutes. Number 10, we would subtract 38 from 70 to find the n's equal to 32. Number 11, I'm going to run through the steps real quick for you. Please make sure if you don't have these steps written down that you are writing them down. The next step would be to substitute 3 in for m. So it becomes 5 times 3 plus the quotient of 6 divided by 3 minus 2. We can do everything in parentheses next, making it 15 plus 3 minus 2. We then have to do the addition first because we come to that first going from left to right, making it 18 minus 2, which gives us 16. Anybody come up with that 16 on their own? Yes. Did I make a mistake somewhere?
I'm pretty sure. Isn't 6 divided by 3 2? Yeah.
Oh, what did I do? Put 3 there? Yeah. How about 2 and how about 17 there? And how about 15 there? Yeah. Me and my twirling around trying to talk and right. Yes, thank you very much. 6 divided by 3 is 2. So 17 minus 2 is 15. Thank you. All right. So 15 plus 2 is 17, minus 2 is 15. Questions on that? All right. So I'll erase that piece. And then as we evaluate this one, we could do what's in parentheses here. That gives us 6 plus 30, right? Minus, and we can do this multiplication outside of that, 36. 36 minus 36 gives us 0. Questions on that? Okay. And then rewriting this using the distributive property. 5 is multiplied by 3, and 5 is multiplied by 8. Any questions on that one? And taking a look at this one, 5 was multiplied by 6, and 5 was multiplied by 4. Questions on that one? And as we take a look at this one, Sally has 4 times as many toys as Trisha. So Trisha is the 1 box. Sally is the 4 boxes. But then we have Sue has 3 times as many as Trisha. So we're still comparing to Trisha. So this is Sally. And we have Sue, and she has 3 boxes. Altogether, there are how many boxes?
8.
8 boxes. Altogether, how many toys? How do we figure out what each box is worth? How about 24 divided by 8? And that gives us 3 in each box. So how many toys does Tricia have? 3 toys for Tricia. How do we figure out how many toys Sally has?
You multiply 4 by 3.
How do we figure out how many toys Sue has?
You multiply 3 by 3.
These toys need to add up to what? 24. Do they add up to 24? Questions on that? This was out of 15 today. Please record your score. As we take a look at your assignment then, two, 3, and 4, we were rounding to come up with an estimate. And number 2, how many of you rounded to the nearest whole number? The nearest 1? 1 person did. What else did you round to? Nearest 10? What did you round to the nearest 10? What else did you round to? Number 2, what did you round to? Whole number. So this would have been 2 plus, or no, I mean 3, sorry. 3 plus 0, maybe 3? Yes? Yes? Anything else? Yes.
Why is it 3?
Because a 5 tells us to round up to a 2. Oh, light bulbs, yes.
Like the number thing that like I would round this to 2 and 15.
So you did to the nearest 10th? You did 2 and 60 hundredths.
No, I did 250 because I did like the gas pump.
Ah, but this was rounding, not benchmark.
Oh, benchmark is 5, 6, 7, and 8.
Benchmark was down here.
Mhm.
Oops.
When I was doing it, I mixed up because I looked up the example.
All right, so number 3, I would assume rounding to nearest whole number. 10 minus 4 gives us 6. Yes? Okay. And number 4, 8 plus 5 gives us 13. Questions on that? Okay, this thing is not picking up anything. I'm taking it off. I don't need one more thing dragging my neck down. Giving me a headache. Yeah. It was a good idea. A great idea, as a matter of fact. But it wasn't working, and I don't need a headache from that thing. All right. So now benchmarks. When we look at benchmarks, we are looking at like 0, 2500, 5000, 7500, or 1. And again, these two are like the next whole numbers on either side. Does that make sense? So it might be like 10, 11, whatever. All right? So what would we use for 2 and 8100s?
275.
2 and 7500s. What would we use for 3 and 7200s?
375.
3 and 7500s. Good. We add those together. 6 and 5000s.
Yep.
All right. Good. How about number 6? Number 6. 12 and 5000s. Perfect. And how about for 7 and 9800s? Ooh. Not 800s, just 8 and 000s, right? Just 8. Okay. All right. And we add those together, and we get 20 and 5000s. 20 and 5000s. Okay. And how about number 7? Number 7. I went through the board. Number 7. Number 7.
6 and 2500.
6 and 2500s.
400. 4 and 000.
There we go. 4 and 000s. Gives us 10 and 2500s. There we go. And how about number 8? 16 and 2500s. And what? Minus 6 and 000s gives us 10 and 2500s. We were subtracting, right?
Yeah.
Okay. Questions on that? Anybody have questions on benchmark? That is the one that is maybe not as commonly used, like in the overall scheme of things, but a lot of people will use it as smaller numbers are used in here, because if you need something that's a little closer to the actual, benchmark is used. Does that make sense? Okay. Rounding can get you farther away from the actual. Benchmark can get you closer to the actual. Okay, so depending on how close you need to be to your actual, you might want to use benchmark. Okay? All right, if we take a look at number 9, number 9, about would tell us that we are looking for an estimate. How many of you use rounding on number 9? How many of you use benchmark? Okay, so I'm going to go with benchmark first, and then we'll take a look and see how that's different than rounding. Benchmark, 1 and 8700ths. What did you use?
I got 187 and I got 2. And for 247, I got 3.
You did what?
For the 247, I got
2 and 4600ths. What did you do for that?
I rounded it to 2.
So you used rounding, or did you use benchmark? You did 2 and 5/10, 2 and 5000ths? Okay. Okay, so 1 and 8700ths would probably be closer to 1 and 7500ths. Yes, no? Okay, so if you were actually using benchmark, probably 1 and 7500ths would have been better, giving you 4 and 2500ths pounds. Okay? If you had used rounding, probably to the nearest whole number, you would have had 2 for that and 2 for that, giving you 4 pounds. Okay? So that would have been rounding, this would have been benchmark. All right? Not a whole lot of difference here. Okay? Yes? Okay. But this, if you use benchmark, is what you should have used. Okay? Does that make sense? All right. Number 10. We want to know about how much change she received. That word about again. She bought a gallon of milk for $3.58. We want how much change she received from $20. I would have used benchmark on this. Benchmark. So we have $20. And what benchmark would you have used for this? Remember our benchmarks we were using were 25, 50, 75. You rounded, which would have been fine. So you used rounding, so you used $3.60, right? Okay, so you used rounding, and that would have worked. That would have worked. And you got $16.40. That's rounding, okay? Benchmark.
It would be 3 and 15.
Okay? So $3.50. All right? So with benchmark, it was $16.50. All right? Either one is acceptable. Rounding, benchmark. Okay? 10 cents difference is all it is. All right? Either one's acceptable. Okay? Next page. All right, so we're looking for an estimate here as well. We have 2 electronic files. We want the best estimate of the total size of the 2 electronic files. What are you going to do with that 3 and 1500ths?
This is 3 and 2500.
You change it to 3 and 2500ths. What are we going to do with that 4 and 8900ths? Gives us a total of 8 and 2500ths. Is that megabytes? MB megabytes? Okay. All right. Questions on that? Yes.
Didn't you do like 4 and 75?
8900ths. If we look at that, 7500ths and the next whole amount, so that would have been 8 and 7500ths and 9, right? And we're looking at 4, or no, not 8. 4 and, I was looking at my answer. 4 and 7500ths and 5. So 4 and 8900ths, all right? Okay. We are how far away here? We are 14 away there. How far are we away here? Anybody? How far away here? 11. Okay, so we're closer here. Does that make sense? All right. Okay. Anything else? All right. And number 2, we're training for marathon. Goal is to run 26 and 2/10 miles a day. Yepers, that's not me. Currently ran 18 and 5/10 miles in a day. Oh, about how many more miles does she need to run in a day to meet her goal? Ooh. Yeah. Yes, Jonathan?
We do 26 and 200.
Oh, well, we want it about. We want it about.
Also, the, what's it called again?
I don't know. What do you want to do?
I didn't.
You subtracted, but are we supposed to do the actual?
Yeah.
With an about in there? No, we want to do a what? Estimate. Yeah, we want to do an estimate. So what are we going to do with that 26 and 2/10? Ezra, to what? Uh-huh. 26 minus 19. Oh, why did you use 19? Tell me that, please. Yep. All right, and what did you end up with? 7 miles. Yikes, that sounds like a lot of running to me. All right, a lot of running. A lot of walking even, you know, that's a lot. You gotta be moving, okay? Okay, questions on that? And number 3, a machine prints 8 banners in 120 seconds. How many seconds does it take to print 1 banner? What did you do?
I did 8 going back to the 20.
You did this?
Yeah. No, not that.
So that's what you told me.
120 divided by 8.
Oh, you did something like this instead. Is that what you did? All right. How many times is 8 going to 12? How many times is 8 going to 40?
5 times.
And what was your label?
15 seconds.
Perfect. And number 4, what place value was this rounded to? What place value? 10. Excellent. And the average distance from Mars to the Sun is about, oh, we want this in standard form. What do we mean by standard form? What do we mean by standard form?
Like 9 or
I need more than that. 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 Yeah, we use digits. We use the numbers, okay? All right, so we have this million comma. So I know I need to be out like here somewhere, right? Right? I need 9 blanks maybe, at the most, right? Because I've got million comma. 141 million. 141 million. There's my 141 million. Okay? Then I need 620,000. $620,000. Right? Well, get a pen back. What do I do with my other blanks?
You're going to add them all here because it doesn't say anything about it.
There you go. Do you see how putting blanks in there will help you determine where things go? Do you do that for yourselves? I suggest you do. That will help you out. Ah. Helpful hints by Mrs. Allen. Number 8, Logan 8. Oh, that is a decimal point. I thought, man, that's a comma. 1 and 438,000 pounds of grapes. His brother Ralph ate 1 and 44 hundredths pounds of grapes. Which brother ate more grapes? Did anybody do this?
Yes.
Did anybody line them up like that to compare? Excellent, excellent. What about the rest of you? What were you doing? What were you thinking?
I wasn't
Come on.
on.
Again, the helpful hint by Mrs. Allen should help you out. Come on. And then you go, oh, the same, oh, the same, oh, not the same. So now I know what my answer is, right? Would you rather eat more grapes?
Ralph.
Oh, are you this one?
Little Ralph. Let's go, baby.
Ralph did. All right?
Oh my goodness.
There you go. If you use the helpful hints by Mrs. Allen, you ought to do quite well. Right?
Maybe.
What's beginning doing?
Maybe.
Well, good for you. But I'm trying to make your life easier, so let's go the easy path.
Yeah, do we add a zero?
You can, but look, we already see a difference. So do we really care about the thousands place?
No.
No. So if they were still the same here, and you get out here, now you add a zero, and boom, now I see the difference, right? Okay? But because I didn't even get out there, I don't really care what's out there. Does that make sense?
Yeah.
Okay? All right. So that's a nice review of everything that we talked about on Monday, right? Monday and before. Okay? All right. So today, we're going to take a look on page 207. What? 207. Is that going to go? Oh, 207. Now, we are skipping a bunch of pages, but that doesn't mean we're skipping those concepts because we're going to continue adding and subtracting with decimals, and that's what all those pages in there are about. But we always continue practicing things. You notice on Math Minute, we just keep practicing stuff over and over and over and over. And you know what? Because we have practiced place value forever, you all ought to know your place values. So on every assessment that we have place values, that section ought to be 100% for everybody, right? Uh-huh. Uh-huh. It ought to be by now. Yes, ma'am.
Can you multiply and divide decimals?
Yes, and we will get there. Just not yet. No, it's not yet. All right. So 207 talks about sequences. Sequences in terms. In terms. A sequence is an ordered list of numbers. We have used sequences. You've used them for a long time. But it's a specific list of numbers, okay? It's not like somebody just slapped a bunch of numbers down. There was a specific list or order that they went in, all right? You have been asked before. You've been asked on Math Minute, but even before Math Minute came into your life by Mrs. Allen and Mrs. College, okay? You were asked, oh, what's the pattern here, right? You might have started out with shapes or colors, all right? You might have had things put on your desk and you were asked, hey, what would come next here? And you would build it, okay? It's a sequence. Now it's an order list of numbers, okay? It's no longer just things on your desk, all right? It's a list of numbers. Each term is a number in that sequence. So this is a term, this is a term, this is a term, this is a term, all right? Each of those is a term, but they're in a certain sequence. They aren't just random numbers thrown on that paper, okay? There's a certain pattern to it, and so we look for that pattern. But I've already asked you questions like, hey, how do we know what that pattern is? How are we going from one number to the next, okay? I've asked questions like, hey, what are those multiples of? Okay? They're not always multiples of each other, okay? Because a sequence doesn't have to be a group of multiples. We're looking for a pattern. How do we see what's happening from one to the next to the next? Mathematically, a lot of times we make a table for our sequences because mathematicians are very organized people. Oh, I thought you were coming up to speech here for a second. Wow, I need to step aside. I knew you were taking over. I was like, whoa, we got somebody taking over my job. So, a lot of times mathematicians put things in a table. It's easy to stay organized that way. It's easy for you to see what's going on. So in this case, if we were to make a table, we would do things like this. And then we would have our table labeled out here, okay? And you've seen tables like this. This would be money. and this would be hours, right? Do you recognize something like that? Okay? So you look at it, and you go, well, these go by ones, okay? And then you look at the top, and you go, oh, how are those going? Well, you start looking at this, and you say, well, if I take $5, I add $1.75. And then I look, if I add another $1.75, do I get $8.50? And the answer is yes. So we're adding $1.75 each time. Okay? Well, how do you come up with that amount? Well, you don't magically have that appear. You look at the difference between the two terms. You're going to have to go backwards. You would take like $6.75 and subtract off the $5. And you get that $1.75. But you don't just believe it that it happens on the first one. You have to check it out. Does it still hold true for each and every term in your sequence here? So you would take $8.50 and you would subtract $6.75. And here's where your subtraction comes in. You got to be careful with your subtraction. Okay, you have to borrow here. You have to borrow here. And again, you get that $1.75. Okay? But you don't just let it happen once. You've got to let it happen a couple of times to make sure that it's going to hold true. Okay? Does that make sense? Because it's not really a sequence unless you can prove it a few times. Okay? Yes, Ezra, question.
So basically what you're saying, if you do that method and tolerance will actually help you get to a positive method.
Yep. Okay? So we check it out the next time, and we now have that $10. Oops, come back. We now have that $10.25. And what are we subtracting from it? $8.50. 5 minus 0 is 5. We need to borrow. 12 minus 5 is 7. I've got some dead pencils out there. Bring those pencils to life, people.
All right,
Come on, bring those pencils to life. And we get that $1.75 again. But you have to make sure that that is really happening in the sequence. Because it's not a true sequence unless that same piece is happening over and over again. Okay? So it was that addition of $1.75 again. But we found that by finding the difference between the terms. It was the difference because we had to go backwards to find it. But we're going forwards to know that it's an addition to keep jumping forward. Does that make sense? So how would we find the next term in the sequence? How would we find the next term?
which one?
How would we find the next term?
You would take 10 and bring 5
$10.25?
and 8 and 6.
Nope. How do we find the next one?
Add $1.25.
There we go. We would add $1.75. Go ahead and add the $1.75 to it. Did you get $12?
Yes.
Yeah.
And that would be in the 5 hours. Okay? So now, we're to write a rule that describes a pattern in the sequence. We're writing a rule in Word. Well, what would our rule be? What would our rule be? What did we do each time? What would our rule be?
To add $1.25.
Now, I'm not going to make you write a complete sentence. You may write a phrase. Add $1.75. This is a phrase we can use. Add $1.75. Okay? Now, the actual question up here was, how much would it cost Jason to rent a canoe for 7 hours? It gave all this information that we could use to set up our table that we originally had there, and we could keep adding $1.75 to get there, right? Does that make sense? Question, Ezra.
So basically, the problem, you have to go in the street.
Ezra, can you do math so I can actually hear you?
So if you have a problem, you're trying to go that pattern and do
Yes.
for 7.
Yes. Yes. Because this is 5 hours, we can do another 6 hours, we can do 7 hours. We have that pretty table up there, we can get there, right? Okay? It's not so pretty table now. It was a gorgeous table. It was.
So beautiful.
It was.
Like, so for $1 million.
So do we understand sequence, term, tables, how we get there? Yes, no? Now, what does all this have to do with we were adding and subtracting decimals? Well, look, did we add and subtract decimals again? It all connects up, right? Okay. Yes, no? Are we good? All right. So, when we write a rule, I'm going to want you to be very specific about it. Am I going to add, blah, 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 subtract, such and such, multiply by such and such? Use a word. Don't just put a sign down. Use a word. A word. All right? Does that make sense? Okay? Questions? When you look down here at part B, come on. Give me what I want. When you look down here at part B, it's giving you the rule. It tells you what to start with, and it tells you to add 1,500, right? And it was the first 4 terms of the sequence. Well, 3,500 is your first term. How are you going to get to the second term? Yes, so off to the side, I should see 3,500 plus 1,500. That will be my second term. How do I find my third term? And it will not be this long, long list here, folks. It will be a new problem. 1,500 plus 1,500. How will I find my fourth term? Again, it will be a brand new problem. It will not be some long list thing going on there. My goodness, my sharpener's popular today. Is that correct arithmetic?
Yes.
So there are the first 4 terms of the sequence.
Oh, okay.
Do those directions make sense?
Yes, it is.
Okay. You have to understand the terminology within the directions. Does that make sense? Okay. Questions on any of this? Let's see what our assignment Okay, so if we look at page 211, on 211, 2 through 6, and then let's take a look at number 7. Give an example of a rule describing the pattern for a sequence, then write the terms of the sequence for your rule.
Oh, yes.
Okay? You are coming up with a rule, okay? Yes? you are going to have to give the first term, right?
Yeah.
So it's like that last problem we just did, basically. Kind of like this one,
Oh.
okay? And then you have to solve it. Does that make sense? Yes?
Yeah.
Okay? Does that make sense?
Yeah.
So if you need to make note of that, you might want to say it was like our example B, okay? You might want to write that, it's like our example B,
It's,
so that when you read it on your own, you remember how to do it. Because most of you won't remember that.
Probably.
it's like me.
Yeah, on what page was that?
So,
Thank you.
I was gonna say that.
Okay? All right. So there's a few problems there on page 211 for you to do, and then if you look on page 212, there's a few problems there. It's due tomorrow, and you may get started on that right now. Let's go.
Wait, we do all of them?
Yeah. And there really aren't that many problems to do. No, we're not packing up soon. Get busy.
We are not getting far.
Don't wish your life away in here. Hey, whoop! Let's go. See how much you can get done. All right, Peyton, what happened? Peyton, what happened?
It kicked me out.
All right. When did it kick you out? I just noticed you were gone.
Like 20 minutes ago, maybe?
Okay.